A function represents a computation that takes 0 or more arguments and returns a value of type t. Similarly, an effect represents a computation that returns a value a in case of success and returns a value e in case of an error. Type signatures tell a lot of story even without looking at its underlying implementation. For instance, a function type takes input args and return an output t. Without args, we cannot run a function. And on successful execution, a function returns a value type t. What happens in case of an error? The function type do not encode that fact. So a function type is actually incomplete. It only talks about happy path and ignores the failure path. Now an effect type encodes success type A, error type E, and requirements R. Requirements is more for interacting with external environment. For keeping things simple, let's ignore this requirements part for now. This stripped down effect type succeeds with type A and fails with type E. Now from the type signature, an effect is self-sufficient. You have an effect, you can run an effect, unlike a function that needs valid args. Now effect is also complete. It not only encodes the happy path with success type A, it also encodes the failure path with type E. Type signatures help us a lot that going forward, we try to make sense of type signatures first and then talk about concrete implementations and use cases. Now zooming out a bit, how do we use functions? We create, compose, and run functions. Similarly, we create, compose, and run effects. To learn and master effect, we need to learn and master these three things. So let's get started with creating effects. The simplest effect we can ever have is effect.void. It's an effect that does nothing. Its type signature encodes that fact by representing nothingness in its success type, and it never fails. Effect.succeed takes a value of type t and returns an effect that always succeeds with type t and never fails. Similarly, effect.fail takes in a value type t and returns an effect that never succeeds but always fails with type t. Now these effects, effect that does nothing, effect that always succeeds, and effect that always fails, are useless all by themselves. But in creating and composing larger effects, these play a very important role, which we will take a look later. Now looking at type signatures again, effect.void is in itself an effect, but effect.succeed and effect.fail are functions that return an effect. Now this distinction is pretty important to understand. Now how do we create an effect from a function? Let's try to understand what it means to convert a function to an effect at type level. A function that takes arguments args and return a value type t, how does the transformed effect, success and error parameters look like? The success parameter is easy because the return value of a function denotes the successful outcome of a function, which is exactly what a success parameter in an effect is. So that one is sorted out. What about an error? A function type do not encode error in its type signature. So there is no way we can reliably fill this error parameter. But if we assume the function never throws any error, then we can replace this error parameter with never. Now finally, args. How do we transform args to an effect? Turns out we cannot. There is no such thing as args to an effect. So in short, a function with one or more arguments cannot be transformed into an effect. But if we assume a function that takes no parameters, then we can transform a function to an effect. That is exactly what effect.senc function does. Given a function, it transforms into an effect on condition the function takes no parameters and the function never fails. Now what about the case where we want to encode error type for a function? For that we can use effect.trysenc, which does not assume a function to never fail, rather fills the error channel with an unknown exception. So far we've looked at synchronous functions. What about asynchronous function that returns promise t? An effect do not make any distinction between synchronous or asynchronous computation. An effect is sync or async agnostic. We do not use promise anywhere in effect. So a promise t is just t when it comes to an effect. And the function that transforms an asynchronous function into an effect is effect.promise. And effect.tryPromise accounts for failure case by filling in unknown exception in the error type. Here is the glimpse of what we've seen so far. As you can see, to transform a function to an effect, we have 4 different utilities: effect.sync, effect.try, effect.promise, and effect.tryPromise. Now let's get our hands dirty and see it in action. So the first effect, the simplest effect that does nothing, is an effect.void. It returns nothing denoted by void, and it never fails. Now that we have an effect that does nothing, how can we run an effect? There are 2 ways we can run an effect: effect.runSync and effect.runPromise. Effect.runSync executes an effect synchronously and returns a value, while an effect.runPromise runs an asynchronous computation and returns a value in a promise. Now there is a lot to talk about effect runtime, but for getting started, this should be enough. Effect.void does nothing, so we can use effect.runSync to run the effect.void and console log the result to see what it does. Since it's nothing, it should log undefined, and there you have it. Now this is an effect that does nothing. Now what about an effect that always succeeds? In this case, it's an effect that always succeeds with value success. In that case, we don't need to log typeof. We can directly run the effect and console log the result. Remember effect.sync that creates an effect from a function that takes no arguments and never fails? Interestingly, effect.succeed and effect.sync have extremely similar behaviors, but with one important difference. Let's see what it is. With effect.sync, we create an effect using a function creator rather than directly providing it a value. Now if you look at the type signature of effect created using succeed and effect.sync, both look exactly same. An effect that succeeds with value string and it never fails. And if you run these effects, they also have same behavior. But the important difference lies in when these values are executed. The value provided in effect.succeed is evaluated at the time of creation, while the value provided in effect.sync is evaluated at the time of execution. This has one important nuance. Let's say I use math.random, which returns a different value each time it's executed. When running this effect multiple times for effect.succeed and effect.sync, the effect created using effect.succeed returns same result every time. But with effect.sync, each execution yields a different result. In a nutshell, we use effect.sync when we want the underlying value to be executed lazily, and effect.succeed when we do not have that restriction. So far, we've dealt with synchronous operations. Now let's create an effect for an asynchronous computation and see how it behaves. To create an effect that holds an asynchronous operation in it, we need to use effect.promise and pass in an asynchronous function to it. But when executing this effect, we get an error that says this cannot be resolved synchronously. An effect is sync or async agnostic. As such, what computation it holds doesn't matter for it. When composing effects, we don't care whether we are dealing with synchronous or asynchronous operations. But when we run an effect, we need to tell the runtime whether we are expecting the result synchronously or asynchronously. In this case, since we are executing an asynchronous operation, we need to use runPromise to execute this effect. And there we have it. Remember when I said we cannot convert a function with one or more arguments into an effect? It's because there is no way we can transform the provided arguments into an effect. Even though we cannot transform to an effect, we can transform to a function that returns an effect. Here is an implementation for such a function. The usage of it looks something like this. Understanding type signatures and playing with them give us a lot of mileage in the journey of effect.ts. There are hundreds of different ways you can create effects, but the one we've shown is all that you need for most of the use cases. Next, we are going to see how to create effects using generators, which is the most ergonomic way of creating effects.